Hello, algebra students, and welcome back to another video lesson. As we begin what is going to be our last unit lesson of the year 10-10. It's going to take a couple days, but we're going to get there. So we're still solving systems, but today we're going to have non-linear systems where one might be a line and one might be the shape of something else, parabolas and exponential equations. So we're still working on solving. Today we're going to focus on by graphing. All right, so as we review very quickly, which method would you use to solve letter A? What method? Well, I would choose elimination in this one. Elimination probably seems to be the most efficient in this one because we can multiply the top equation by 2 so that the x variable will be eliminated when we add. All right, so if we multiply that top equation by 2, we're going to get 18x and negative 18x, so we can add them so that it would eliminate. How about letter B? What would you use for letter B? I would probably use substitution here, because we already have one equation with a variable by itself. All right, so we have that one equation on the bottom here where y equals this, meaning we can put it right in here for that y value right there. And then we could figure out what x equals and work backwards from there. So remember to think about the different methods that we've taught, the methods that you have utilized. Now, again, today's focus is more so on systems of equations with one linear and one quadratic. All right, do you remember the shape that a quadratic equation makes? Well, it's a parabola, an upside down U or an open U. So here's my question for you. Can you draw a sketch of a line that has a parabola either on it or the line and a parabola together? What might it look like? Well, one possibility on a graph is where we have a parabola that opens up and a line goes through that parabola twice. Another possibility might be, where the line doesn't even touch or intersect the parabola. And last but not least, where maybe it just intersects exactly once. How does this relate to solving systems? Well, remember when we graphed way back at the start of solving systems, we had two linear equations and we were looking for their intersection points. So it's going to be the same concept today. We're trying to figure out where does the parabola and where does the line intersect, because those could be the solutions. Now, one method is to check our answers, right? Can we tell if the -1, 5 is a solution to that system? Meaning we plug in -1 for x and a 5 for y, and we see, does that work in both of them? So here's what the top one is. -1 squared is +1 plus 3. Does that equal 5? No. So we could stop our, oops, I messed up again. You see, I already forgot. I forgot the 2 out front. So we got to put a 2 here. 2 times -1 squared, or 2 times 1, becomes 3 plus 2, which is 5. Does that equal 5? Yes, it does. So we've still got to check the second equation. Does 5 equal 2 times -1 plus 3? -2 times 1 is -2. -2 plus 3 is 1. Does that equal 5? No. So it worked in the first one, but it didn't work in the second one. Therefore, it is not a solution. All right, it has to work in both. So the question becomes, how can we find the solutions or solution to that system? We are going to go back to Desmos and talk about graphing in Desmos. Remember, when we graph, we are looking for any intersection, because that means that point is shared amongst both graphs. First line, y equals 3 plus 2x squared. All right, so there's my parabola. The second line was y equals 2x plus 3. Lo and behold, we've got an intersection point at 0, 3 and an intersection point at 1, 5, meaning those 2 points are the solution to this system because it does intersect at both points. So we would want to list 0, 3 and 1, 5 as solutions. And again, you could check by plugging them in and seeing if they work. They both will. All right, so why don't you pause the video and try this one. Y equals x squared plus 6x plus 7. Y equals x plus 1. How many intersections are there, which means how many solutions are there? All right, y equals x squared plus 6x plus 7. Y equals x squared plus 6x plus 7 is our first one. Y equals x plus 1 is our second. Once again, we have 2 intersection points on the parabola and the line, meaning those 2 points are the solution to this system. How many intersection points are there? 2 intersection points. Therefore, the solutions are -3, -2, with -2, -1, right? Those 2 points are part of both the parabola and the line. Here's the next one. Y equals x squared plus 2x plus 4. Y equals x minus 2 squared. Why don't you pause the video, go to Desmos, and try to graph those. All right, to Desmos we go. Y equals x squared plus 2x plus 4. Y equals the group x minus 2, and in parentheses, quantity squared. 2 parabolas. All right, it looks like the only intersection point is going to be right there, because this one's going to keep going further away from that blue line. This one's just going to keep going further away from that blue line. Never going to intersect up above. So we only have that one intersection point, 0, 4. All right, so we can say that there's only going to be one solution, one intersection, and it is the point 0, 4. One more example. Y equals x squared plus 3, and then y equals negative x squared plus 8x minus 12. See what you get. Okay, let's go back to Desmos, maybe. There we go. Y equals x squared plus 3. Y equals negative x squared plus 8x minus 12. Oh, look at what happens. One is opening up, one is opening down. Do those 2 parabolas ever intersect? They do not. They do not intersect. All right, how many intersections? None, 0. So what are the solutions if we don't have any intersections? No solutions. Now this could happen with 2 parabolas, like this example. I cannot spell. No solutions. So it could happen with 2 parabolas. It could also happen with a parabola and a line. As we saw earlier, it could also happen with 2 lines. All right. So for today, we're focusing on using Desmos to help us solve these and figure out how many intersection points and what does that tell us about the solutions. If you have any questions at all, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.